Okay, so this is number 3 on the new extra practice sheet. Okay, and this one has a sign, and there's a guy over here that is pulling the sign, and a guy over here that is pushing the sign. Okay, so you have to kind of look at the picture and see. So I'm going to call it sign, left, and right for the guys, okay? Okay, so first let's decide who's interacting, and then we'll decide what they're doing. Okay, so the left guy is touching the sign. The right guy is touching the sign. Everybody is touching the floor. Right floor, sign floor, left floor. Okay, and everybody's interacting with the earth. Left earth, sign earth, right earth. Okay? All right, so that's all of the interactions that we have. So let's draw diagrams of everybody. So again, put them in the order that you see them in the picture, and that's going to make it easier, I think. Okay? So we have the left guy, the sign, and the right guy. Okay, so let's see. Let's start with the left guy. All right, he's going to have a weight because you always do. So that's the force of gravity on the left guy from the earth. Okay, and let's see who else is interacting with him. All right, so that's the earth. The floor is pushing him up because that's a normal force on a surface. So that's force of the normal on the left guy from the floor. Okay. And he's interacting with the sign. So let's do that one in a minute. Okay, so let's get everybody else straightened out. All right, let's see, what was his mass? Okay, 2 men are trying to move a 1,200 Newton sign, but it will not budge. The man on the left weighs 700 Newtons. Okay, so look here, right? He weighs 700 Newtons. That's what you're looking for. So in the quiz, a lot of people put numbers in all random places. Okay, the fact that I forgot the numbers and had to put them on board, I don't think helped. All right, so that has to be 700. So this has to be 700. Sorry, 700. Okay, because it says he weighs 700 Newtons. All right, so let's look at the sign. Okay, I'm gonna make this one a little bigger because force of gravity on the sign from the earth was given as 1,200 Newtons. Okay, because it said a 1,200 Newton sign. That's the way you say it to say the weight. 1,200 Newton sign. So the ground has to be pushing up, or the floor, I think I called it, right? The floor has to be pushing up also with 1,200 Newtons. Okay? This brings up another point. Make sure all your labeling is correct, because I saw a lot of people label different in different places. So over here, if I'm calling this guy L, I have to call him L here, I have to call him L here, I have to call him L here. Okay, it has to be consistent. Okay, all right, then we've got the guy on the right. He also has a weight, so that's the force of gravity on the right guy from the earth. And he also has a normal force from the floor. Force of the normal on the right guy from the floor. All right, and let's see, the right man on the right has a mass of 60 kilograms. So when you see mass of 60 kilograms, that's trying to tell you the weight. Okay, so you have to multiply 60 kilograms by 10 newtons per kilogram, and I get the right guy's weight as 600, so the floor is 600. Okay, now, let's do the sign first, because the sign is the most obvious thing, and he has the most things happening to him. So, on our interaction diagram, let's just look at the sign. Okay, and I know this is kind of getting sloppy here, okay? So who's interacting with the sign? Okay, we have the guy on the left, the guy on the right, the earth, and the floor. All right, so he has 4 guys interacting with him. We already did the earth, and we did part of the floor because we did the normal force from the floor. Okay, so let's look at the left guy and the right guy. So on the sign is feeling how from the left guy. Okay, is the left guy pulling or pushing? So look at the picture. See this guy on the left? He's pulling the sign. Okay, so whoops. There. Okay, so the sign is being pulled to the left. So that's a tension of the sign from the left guy. Okay, the right guy is pushing the sign. Okay, see him on the right? He's pushing the sign. Which way is the sign feeling it? Okay, the sign is feeling it also to the left. Okay, so that's a normal force on the sign from the right guy because he's being felt moving to the left. He's being felt the push to the left. Okay, and it says that the sign will not move, so I know the forces have to be balanced, which means there has to be a friction force facing this direction on the sign from the floor, because that's everything else there could be. If there's no friction, this is going to be like the bowling ball, tap, 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 getting faster, but that's not happening. It's balanced. Okay, now something else I noticed on the quiz, some people like to put multiple frictions, okay, from I don't know why. Just because there's 2 arrows to the left doesn't mean there has to be 2 arrows to the right. They just have to total the same amount. Okay, friction is a single interaction with the floor. It's not 2 different things just because there's 2 arrows on the other side. Okay, friction's a single interaction. Okay, so let's see what we've got. So the man on the left, it says applies a force of 250 newtons. The man on the right applies a force of 100 newtons. So if we go back and add that to our picture, the man on the left is pulling with 250 newtons. The man on the right is pushing with 100 newtons. Okay, so total on this side, I have 350, which means my friction has to be 350 because the sign isn't moving. The forces have to be balanced on each side. Okay, not the number of forces, but the total amount of newtons that there are. All right. Okay, so the sign looks good. Now, let's look back at the left guy. I'm looking for his pair. Okay, the only other thing he was touching was the sign. So I'm looking for that LS pair. Okay, so let's look at the sign diagram. Where is the LS pair? SR, SE, SF, SF, SL. This is it right here. See, because I have L and S. That's the pair. Okay, so if the man is pulling the sign to the left, then the sign is pulling the man to the right. They have to be opposite. So since this one is pointing to the left, the pair force has to point to the right. Okay, it's still a tension, and then the feeler dealer are going to switch places, and this amount is going to be the same. Okay, this is the pair right here. Okay, so the man, not what he's doing, what's being done to him. He is being pulled to the right. He is pulling to the left. He is being pulled to the right. Okay, all right, he's also not moving, so that means against the floor. His feet have to be providing friction, okay, on the left guy from the floor of 250 newtons to keep him from moving. These now have to be balanced. This have to be balanced, okay? They're not a pair, they're just balanced, all right? Okay, now let's look at the guy on the right, all right? So now I'm looking for the pair that includes the guy on the right and the sign because I've already done the floor, I've already done the earth. I'm looking for the pair between the right guy and the sign, okay? SF, SF, SE, SL we already used. Here it is, SR. See, between the sign and the right guy. So this is my pair. The right man is pushing the sign to the left, so the sign is pushing the man to the right. They have to be opposite. So I'm going to change the feeler dealer, and it has to be the same amount. So that is another pair. Okay, the man on the right also is not moving, so the last thing we add is the friction. So we know his feet must be digging in. Think about his feet digging in if he's not going to move, right? Or if he was on ice, he would slide out the other way. RF, that also has to be 100. Okay, all right, so that's the whole entire thing.